All right, hey folks. I'm going to talk to you today about a concept called limiting reagent. You may have also heard this as something like limiting reactant, most likely last year. And so the idea is that we need to figure out the products of a chemical reaction. So sometimes we need to figure out the products of something and their quantities, right? So if I have two things mixed together, how much is actually being made? Now, we use a stoichiometric molar ratio. And so we've been in the business of using conversion factors all this time. And so the stoichiometric molar ratio is just going to be another conversion, and I'll show you how to use that. We use both reactants and we convert them into the same product. Now, sometimes when we are doing this, you'll also convert one product into another product, or one reactant into another reactant. So let's say that we have A plus B is giving you C plus D. We might say, well, given A and B, what is going to be the product of C? Or we could say something like, given B, how many moles of something is needed to react with A? So we need to be flexible here, but for the most part, we're thinking about going from reactants to products. And the lower yield is the correct yield. And so this gives the idea that one thing is in excess and one thing has just the perfect amount. And so we'll go over this a little bit more in class as a concept, but I just need you to mechanically work through a couple of problems first. So one of the reactants will always run out first. And just imagine you're at home making sandwiches. You can only make as many sandwiches as you have slices of bread. Or you can only make as many sandwiches as you have pieces of bologna. That's a gross sandwich, but so there's only so much that you can have. The rest of the stuff will be called excess, and that language will come to us over time. So here's a bit of a question. This is usually what they'll look like. It's two masses here and going towards a final mass. Now, if we have 10.6 grams of copper and it reacts with 3.83 grams of sulfur, how many grams of Cu2S are created? Now, I have a bit of a flow chart here on how we can go about answering something like this. And so first things first is that you want to balance your chemical equation. So I'm going to look right here at this balanced chemical equation and I say, well, I have two coppers on the right, and so that means I need to have two coppers on the left. I got one sulfur, that's okay. So we're good over here. You need to find the moles for all knowns. And so let's do that right now. And so 10.6 grams of copper. And I need to create this into moles, and so I know that the molar ratio for copper, the mole mass for copper is going to be 63.55. So 1 mole is over 63.55 grams. And just for consistency, remember this is the mole ratio, this is the molar mass step that we're using. And then the next thing that I need to do is use a mole ratio. So I know that I'm dealing with two coppers for every one, and if you don't see a number in front there's an imaginary one there. So I know that I have 2 coppers for every 1 Cu2S. I always want to put what I want on top. So I have 1 Cu2S for every 2 coppers that I have. And again, just for the color here, I'll show you that this mole ratio step is in red. And so this right now is broken up to get into moles at this step, and then into moles of copper 2 sulfide in this step. And then finally it asks how many grams of copper 2 sulfide are there. So we need to multiply that by the molar mass of copper 2 sulfide, which is 159.16 all over, and that's grams, all over 1 mole of Cu2S. And so, as you can see here, that is just another molar mass calculation here. And as we go through, 10.6 divided by 63.55 times 1 divided by 2, and multiply all of that by 159, which gives me an answer of 13.3 grams of Cu2S. Okay. Now, we might think that we're done, but did we make 13.3 grams? We actually have to do this for both. So we have to do this for each known quantity. So again, I have to do this with sulfur. Now, notice the difference here when I go through this. 3.83 grams of sulfur times I forgot my times up there, times the actual molar mass of sulfur. So 1 mole all over sulfur is worth 32.06 grams times 1 mole of Cu2S all over 1 mole of Cu. So here, the difference between S up top, so this 1S and this 1 Cu2S has a 1-to-1 ratio. So this is our mole ratio. This is getting things into moles. And then finally, we need to get this into grams at the end. Now, luckily, at the end, we're getting into the same product, so it's still the same number. We don't need to do 2 molar masses there. And one more time, that is our molar mass calculation, so I'll highlight that there, and the answer should be 19.0 grams of Cu2S. Here's the kicker when it comes to limiting reagent. The limiting reagent here should be copper. So this is my limiting reagent, and the reason why is because this is the smaller and this is the bigger result. And so with the limiting reagent, we can only make as much as our limiting reagent tells us, and usually this is going to be highlighted by having a smaller result in the very end. Okay? One thing I do have here as a note is just answer any rider. Sometimes it might say how many moles are resulted or how many grams are resulted, and so I put this here as a note. This is a rider and it states what to find. So here the rider in this question was how many grams of Cu2S should be created. Try a couple onto that program that I made for you guys, and hopefully this should make sense. You can also do all of this with gases, and you could do all of this with solutions. And of course, we just did one with masses. And even trickier still, you could do mole ratios that go in between each one of them. So you need to be pretty flexible with your ability to work through known quantities.